Hello, and welcome to the next segment of the Life Sciences and Technology series. Today's topic will be lab and bio-waste. First thing you need to know is that not every building requires a lab or bio-waste system. You need to do a upfront due diligence analysis based on what types of spaces you're going to lease in that building, and whether it's a BO1, 2, or 3, and whether you have a biological system that is separate from your lab waste system. It's also important to understand if you need to have an active kill system or a passive treatment system. A passive treatment system is really limited to a lab waste discharge. A passive waste system consists of, in most cases, a tank under a sink for points of use, or a tank at the last point the lab waste water will flow through before it enters the municipal water system. In both cases, it's typically a limestone passive waste system, and all this is trying to accomplish is neutralizing the acidity to a point where it meets the requirements of the municipality. Those are the two big differences. Once you break it down to a biological waste system or a lab system, you have two options. You have the option to do it as a continuous flow, where you can flow waste from your labs and your manufacturing suites continuously, and the water does not need to stop and be contained. You have enough flow throughput to be able to say it's a continuous flow system. The other option is a batch system, where you have hold tanks that would then kill the volumes of water that would be either neutralized for acid in the case of a lab waste, or killed in the case of a biological lab. Then they're discharged. The reason this is real important, and this gets into a detail once you have tenants in occupied space, you need to determine the throughput, the flow of lab waste, how much lab waste is being generated and how much is dumped at any one given time. So in the case of sinks, you have, generally speaking, the flow rate of a sink that flows water. It's easy to calculate. In the case of lab waste and bio-waste, it's a little more complicated, because you need to have a very good way to manage the lab users, the manufacturing users, the research R&D users, so that you understand the maximum flow of waste, whether it's lab waste or bio-waste, in a given period of time, so that your system is not overrun or overcome. The point I'm making is, if you have a maximum flow rate of 10 gallons per minute, that's a given number and that's easy to work with. But what happens in most cases, in most buildings, the systems are dumping larger volumes. Think of a bioreactor. You could have a 10 liter, 50 liter, up to 2,000 liter bioreactor. And if they decide at some point that that needs to dump down the biological waste system, that's your maximum flow in a given hour, or in a given 2 hours, depending on how you discharge that waste. The point I'm making is that the systems need to be designed carefully to understand the maximum flow rates within hours, within half days, and within whole days. And then in some cases, the people that run the buildings need to manage and work with the scientists and the manufacturing portions of the industry to maintain the systems so that you don't exceed their capacity. You don't want to overrun the systems. If you overrun the systems, the volume that flows into the bio-waste or lab waste tanks exceeds the volume that they can receive, and then it goes into the vent and overflows into the room, into a secondary containment. That then is a lot of work to clean up and decon. So making sure that you have the right people in the right place to design and analyze these systems is real important. In summary, it's important to know whether you require an acid waste or bio-waste system, if you need to have a passive system for mild chemical use, if you need to have a active system, you need to then determine, is that active system for both biologics or lab waste, or both? Will it be a chemical kill system or neutralization system, or will it be a heat-based system to kill live biologics. Thanks for joining this segment on Lab and Biowaste. Looking forward to the next one. Thank you.